Okay, so guys, look at your plate tectonics activity, okay, and read along with me. In geologic terms, a plate is a large, rigid slab of solid rock. The word tectonics comes from the Greek root to build. Putting these two words together, we get the term plate tectonics, which refers to how the Earth's surface is built of plates. The theory of plate tectonics states that the Earth's outermost layer is fragmented into a dozen or more large and small plates that are moving relative to one another as they ride atop hotter, more mobile material. Before the advent of plate tectonics, however, some people already believed that the present-day continents were the fragmented pieces of pre-existing larger land masses or supercontinents. Plate tectonics is a relatively new scientific concept introduced some 30 years ago, but it has revolutionized our understanding of the dynamic planet upon which we live. The theory has unified the study of the Earth by drawing together many branches of the Earth sciences, from paleontology, the study of fossils, to seismology, the study of earthquakes. It has provided explanations to questions that scientists had speculated upon for centuries, such as why earthquakes and volcanic eruptions occur in very specific areas around the world, and how and why great mountain ranges like the Alps and Himalayas formed. So we're going to go ahead and look at the procedures. You're going to mark out some of these because they're already done for you. The first procedure has to do with the crustal plates. It says to cut out the earth plates. Would you please put an X over step A because that's already done for you, or we're not going to do that part. Please mark out B. We're not gluing anything onto construction paper or cardboard. C. Color or shade the land areas in yellow. You will do that. D. You will color or shade the water in light blue. And E. We're not going to do that one either. Use a dark pen to draw in a line that separates North and South America. We're not going to do that either. Okay, I want to call your attention to everybody get out the map that you received. Look at the map. And I want you to really notice that it is possible that an entire plate will have two different colors on it. Okay, if you notice here the South American plate, this is the continent of South America. What color are you going to color it? Yellow, okay? And then the water out here, the ocean, you're going to color it blue, okay? So just notice that just because this is one plate, that does not mean it's all colored the same. Back when we talked about continental crust and oceanic crust, you may have thought that the entire plate was one kind of crust, and that's not true. As you can see here on the South American plate, the west side of the plate is going to be thicker. Okay, it's your continental crust. It's thick enough so that the land mass can stand up out of the water, while the east side of the plate is going to be thinner, and it's oceanic crust. Okay, so I wanted to call that to your attention when you started doing the coloring. Go back to the instructions, please. And it takes them a second. There we go. All right, plate motion. Okay, plate motion. Step A, name the plates. Please mark that out. That is already done for you. Step B, place arrows below the plate names to show the plate motions. We're going to do this example together. The very first one, North and South American plates are moving westward. So if you'll look at your map, you want to find the North American plate. And everything you do on here, you want to do in pencil at first. Every mark must be in pencil at first. Okay, so the North American plate is moving westward. So we're going to draw an arrow pointing westward. Okay, and we're going to put that right underneath the name of the plate. So we're going to do this. Okay, the South American plate is also moving westward. So we want to do this. Notice the arrow goes right underneath the name of the plate. Now, I want to call your attention to something. I want to remind you of our directional terms. Okay, we have north south. What is this? East and west. All right, if we're anywhere in the zone between north and east, that is the northeast. But what you need to understand is if it is closer to north than it is to east, this is northeast. And the symbol would be NNE. If it's in this part of the northeast quadrant, pointing toward the northeast, but it's closer to going east, it's going to be east, northeast. Okay? It's going northeast, but it's more east than it is north. Carter.
Would you like us to write this down?
Unless you're going to remember it, it's a good idea to write it down somewhere. I would maybe put it on the back of my map. Okay? Going this direction down here, what do we have? Southeast. But if it's closer to east, like if the arrow says it's going east-southeast, it's going to need to be closer to going east than it is going south. Okay? What would this be in this area? South, southeast. Okay? Where this applies, and so on, this would work for southwest and northwest and everything. Where this applies, let me give you an example. Give you guys a chance to write this down. Everybody look back at your instructions, at the directions of the plates, the plate movement. Notice number 5 here, the Indo-Australian plate moves north-northeast. Okay? Northeast is going to be this direction, but it needs to be further north. Now, I'm going to go ahead and do this one with you because it's a little bit confusing. On this paper, they're calling it the Indo-Australian plate. And when you go to your map, they are 2 separate plates. Notice you have your Indian plate and the Australian plate. Go ahead and do north-northeast arrows on those plates. All right, next section. Section, or number 3, earthquake watch. You're going to use the data on the back of this page to plot the earthquakes. There are 24 of them you're going to put on your map. Again, do it in pencil. Pencil only. Now, it tells you to use a purple colored pencil to put an X where each earthquake is located. Personally, I think you should just use a regular pencil and later go back with a purple marker and put the X, color the X's purple. Okay, the volcanoes, you're going to use red, and you're going to plot them with O's. I would use pencil and then go back later with a red marker and go over it with red. Okay, the plot points are back here. Your volcanoes are in the first column. Your earthquakes are in the second column. Pay attention to how you plot each one. Okay, you're going to use latitude and longitude in order to do this. So let's do Colombia. This is an earthquake. These are earthquakes that occurred between February 28th and March 6th of 2007. It's going to be 2 north and 77 west. So go to your map. Here's the equator. 2 north is going to be a little above the equator. And you're going to need to find 77 west. Okay, if you look up here, here's 60, here's 90. Whoops. Here's 60 and here's 90. So it's halfway in between. Okay, there are 30 degrees difference between 60 and 90, and 77 is real close to being right in the middle. So you're going to come straight down from there to 2 degrees north, and you're going to put whatever it is for earthquakes. Earthquakes, again, are X's. Okay, so you would put an X there. You're going to do that for all 24 earthquakes and all 24 volcanoes. Lastly, you're going to do the mountains right here. The mountains, let's say that you have a mountain range going like this. Okay, all you're doing is brown triangles along the range. And you're going to label them. Okay, again, I would do them in pencil and then go over them in brown marker. So if, let's say that these were the Alps, you would label them Alps. You're going to need to look these up. You can use the internet, whatever. Okay? Yes, Cassidy. You do not label the earthquakes and volcanoes. That's an excellent question. Do not label the earthquakes and volcanoes. Okay?